Okay, let's solve in 39 question is determine whether the argument is valid or invalid. Okay, pero this is a word problem. It's hard when it's a word problem. Discover what is the most important statement inside the word problem. So, suppose I saw you are infected with the measles. Okay, this is one statement. So we define let definition let P like you are infected with the most measles. Now let's define another statement Q like let's see it can be transmitted. It can be transmitted. It can be transmitted. Entonces it can be transmitted. It can be transmitted. Transmitted. Okay. And one more. Suppose another. Let me continue to read the results are great. It's another statement. Suppose define are like the results are great. Okay. The rest is formed by the combination of this. Okay, now I want to express this in symbolic language. Let's see. Okay, now let's go to this translate to the symbolic language. Okay, the first premise 1 is a conditional statement because it's the combination if then. So it's P arrow Q. It's a premise number 1 is a conditional statement because you see it's the combination if then, and the antecedent is P and the consequent is Q. Okay, now the premise number 2. And premise number 2, this is no condition. No, it's no condition. How do you know it's no condition? Because it's the results are great, and you can see the word "am" to indicate conjunction. Is the results are great is are conjunction. Conjunction what? Conjunction it cannot be transmitted because the negation of you. This is the premise number 1. Okay, and after that you see the word therefore. Therefore indicates a conclusion. Conclusion in symbolic language indicated by this 3 period. Therefore, if the results are great, then you are infected with measles. Okay, so this is again if then is a conditional, and the condition is the results are not great. The results are not great is the negation of R. This is negation of R. Aaron. Then you are infected with the measles, case B. And this is the symbolic language to write this problem. Okay. In 39, this is symbolic language of our problem. Symbolic language. Now you analyze every possibility of the statement using different true value. Remember, in this case we have 3 statements, P, Q, R. Therefore we have 8 possibilities. How you write that? You write You put true here, true, 4 times. After you put false, and after, in the first 4 combinations, you write the traditional, traditional combination: true, false, true, 4, and you repeat this part again here, and you have the 8 combination. There are many ways to do that. However, I recommend this way. Okay, let's do it step by step. Premise number 1. This is premise number 1. Look, this is the premise number 1. Look, this is the premise number 1. Okay, and the premise number 1 is a conditional, and the conditional is always false when the antecedent case P is true and the consequent case Q is false. I fall here and fall here, and the rest is true. True. Okay, done this part. Now let's go to the second premise. This is the second premise, but the second premise involves negation Q. So let's analyze one extra column that represents negation Q. Negation Q is completely opposite true value of Q. It says false, true, false, true. And ready. There is R conjunction negation Q. Okay, we're working basically with this column is R and this column is negation Q, and this is conjunction. A conjunction is true only when the both are true. See, one is false, is not true. So it's true, is false. This is false, of course. This is true and true is true. This is true and false, false. False and true is false. False and false, of course, false. False. True and true is true. And true and false, false. This is the premise number 2. After that, remember, you form the conjunction between each premise. So basically, I analyze this column and this column. Conjunction is true when they both are true. This is false. This is false. This is, let me see. This is true here, and this is false. True and false is false. Okay, again, false is false. This is false. This is false. This is true. And this is false. Okay, very well. Okay, now let's go to the conclusion. The conclusion is conclusion. Look at that. Conclusion is this. Conclusion. C. Conclusion. Conclusion is the conditional statement where involve R, negation R. Let's find one extra column to represent R negation. R negation is negation R. Negation R is false, true, false, true, false, true, false and true. Okay, now is negation R conditional B, and this is the conclusion. Conclusion. The conclusion then is, you see negation negation R and P. So basically we compare this column and this column. So S is only false when the antecedent is true and it's false. So the only false is here. This is true, the antecedent, and false, the consequent, and one more here, another false. And the rest is true. True, 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 and true. Okay, finally, the last column is the combination of the two premises, and you forming the conditional statement with the conclusion. So basically I am using this like the antecedent and this conclusion like a consequent. I need to discover this condition is false only when this is true. It's true here, and the conclusion is false. The only true we have here is this true, but it is not false, it's true. So it's true, and the rest of course is true. True, 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 and true. The conclusion always is true. When it always is true, this is tautology. Tautology. And that means that the argument is valid. Valid.